So ethix, we're a lab for innovation ethics, which is a quite important add-on to the description, but it often gets lost a little bit. And what we're trying to do is to put ethical reflections into practice. So, I mean, probably most of you have, in the context of machine learning and AI, have recently heard about, oh, we need to bring ethics to the table, we need to include ethical reflections, but often these reflections stay at a very top-down level and hardly trickle down. And what engineers usually say when we come and say we need to think of ethics, they think, oh no, now the ethics people come and they will tell us we're not allowed to do this and we're not allowed to do that, and that is also bad. But we actually have a very different approach to this, and we think that ethics shouldn't be there to tell people what they can or cannot do, but to actually make them reflect on their choices that are sometimes explicit and sometimes also implicit when they develop machine learning or other types of innovations. So today I'm just going to take the example of algorithmic bias for some more social science, philosophical reflections on how that impacts trust and also challenges some of the values we defend, at least in our European context. See, is this working? No, okay, no problem. Yeah, the examples of bias are numerous. I'm just going to mention a couple of ones. We have them often in the context of gender or race. So the first example was the Apple credit card. It was quite public last November when Apple brought out a new credit card, and they and it actually gave women a much lower credit limit than men, even though they had the same credit score or even higher credit scores and incomes than men. This produced a huge scandal PR-wise for Apple and that credit card. The second example is an example that is also quite well known, that certain programs, here we talk about image recognition, are actually perform much better on different groups of people than others. So in this example, gender, they tried to identify gender from images, and white males were identified much easier, like I think, yeah, had a identification rate of 99%, and non-white females, only 65% were identified correctly. And finally, an example that is maybe a little less common, the idea of having household items from lower income countries being less well identified than richer income countries. Again, an example for bias in certain algorithms that can happen. And most of the times I would argue these biases, they are not intentional, but actually happen by accident. So now, from a more social science perspective, philosophical perspective, what do we talk about when we say bias? And what do people understand that are not statisticians, that are not data scientists when they hear the word bias? First of all, it's a tendency. That's a pretty broad word, but I mean, it makes sense, right? We have the idea something should be neutral, but no, a biased algorithm is an algorithm that has a tendency towards certain outcomes. From a more technical perspective, it's a systematic error, right? We try to make a prediction. The prediction is somehow biased against a certain group and therefore erroneous because this bias is not intentional. When we look more from the social perspective, it is a personal or sometimes unreasoned judgment. So when we think of biased people, and we heard about that all of us are, of course, biased and have these heuristics that we use in our day-to-day lives, we often think of this as, unreasoned judgment that is based on some sort of prejudice often. And these examples that I showed just before are instances of such prejudice where they actually hurt certain groups of people. In the case of the credit card, for example, where female customers got much lower credit scores. Now, in the context of machine learning, we can find different origins of this bias. So like I said, I'm not a technical person, so this is probably very basic, but just kind of trying to understand also from then this, a practical side where we have to challenge these things. I think this is just a little bit of a recap, and we've heard several of these examples also before. So the example of the wolf and husky classifier, or when algorithms are overfitted to certain biased training data sets. But what I think is mostly important when we look at also the question of trust and trustworthiness is this idea of the social bias, that we have a biased outcome and actually a discriminated group of population or a group of people as an outcome of this bias. Now, sources of bias, of course, there are numerous. We've heard several ways of identifying bias from a technical perspective. Irina, that was talking in the first part of the trust track, she highlighted the idea of the data, so that bias often originates in the data set. And that idea of having to assure a balanced data set. And I would say this idea of balanced data set means that the data we want to have to train our algorithm needs to be somehow representative for the population that we're going to use our algorithm in. And that is often more challenging than it sounds in practice because we have limited data, so we need to make certain payoffs there. Second, we have the algorithm, and there we have all these statistical biases that can come when we train this algorithm. We have the humans that program the algorithm, and there this idea of heuristics and personal biases comes in again, but sometimes this is merely the idea that the people that program the algorithm, they're quite far away from the use cases that they'll be used in. So if you think about this one example I mentioned about household items being, an algorithm being much worse at identifying household items in poor countries, that is probably because, first of all, the data set was biased to household items from rich countries, and that was the case because the people that were programming this probably came from rich countries and not lower income countries. I mean, this distinction between algorithm and coders is a bit artificial maybe, but it's interesting to think of where we can tackle bias afterwards. And finally, and that's an element that Bradley just mentioned also, and I think is extremely important and often gets a little bit overlooked, is the idea of the bias can also originate from the humans that will deploy these applications and these algorithms in day-to-day life. And especially if we think of algorithms that classify humans, for example, that give them credit limits or that do CV scans for hiring. Sometimes these decisions are completely automated, but often these machine learning tools are also used in not to completely automate, but to support actually decision processes in certain aspects. And that's where the thing becomes really tricky, because the people that deploy these algorithms, the users, I would call them, they often do not have a data science background and often have a very low understanding of statistics in general, I would say. So if they receive an output that tells them, well, with a 70% chance, this person is, I don't know, a valid candidate for us or is not a valid candidate, then for them that means, oh, 70%, that's more than 50. That means that this is a pretty good chance that I should take this decision on that way. And there is actually plenty of examples also that aren't maybe so strongly, or that are also linked to bias where this has happened. A really famous one is the German Ministry of Migration has deployed a tool that does automated dialect recognition to speed up certain processes of granting asylum. And this tool was also based on natural language processing. It was a pretty poor tool, so the performance of it from a technical perspective was extremely poor. But what was even poorer was the way it was used, because the developers of this tool told the client, which was the Ministry of Migration, well, this is can just support you in your decision. But the people that actually used it and the people that were treating these cases, they used it as they saw the number, oh, with 77.58% chance, this person does not come from the region she or he is saying they do. And this number, 77.58, sounds extremely accurate to a person that does not understand that does not have any statistical knowledge. And this meant that people actually got rejected their asylum claims based on a tool that was, first of all, technically very poor, but also employed in a very poor case. And that's something that I would just like to kind of throw in the room, that often this element gets a bit lost when we speak about machine learning. Now, the consequence of bias, I mean, very obvious. We have this idea of unjustified discrimination. And that really challenges this idea of fairness that is, I think, at least in our Western societies, a very core principle. I mean, not only ethically, but also legally in many cases, a thing we need to look at. But it also creates a phenomenon that is a bit more linked to the track we're in, this idea that people actually start to trust applications less that have shown these biases. And we can see this on both this idea of a social bias, but also of the statistical bias. So this mistrust can also happen when an algorithm performs poorly, when we see it has a lot of, false negatives or false positives. If a user interacts with a system that keeps making mistakes, at one point he or she will stop trusting that system. So bias can challenge trust in quite a substantial way. Now, I'm actually not an ethicist, but I come from a company that does innovation ethics. I just want to make this link to these high-level principles that I mentioned before for AI. Just this idea of fairness when we talk about bias is really one of these core ethical principles, for example, of the European guidelines for trustworthy AI, but they also are in many other guidelines that are out there. I mean, to make these a little bit more workable, they translated these ethical principles into these 7 requirements. Not going to spend a lot of time, but we can see that this idea of technical robustness and safety and of non-discrimination and fairness are really closely related to the problem of bias. Now, a little bit more on the philosophical maybe reflection behind it and the white paper that was mentioned before. So at Ethics, we thought that trust and trustworthiness are these topics that keep coming up in the context of innovation in general, but AI and machine learning in particular. And a lot of people talk about how we need to create trust in the technology and we need to make people, also not only the users, but also just the general population trust technology more. But very few people actually think of what does that mean. So what does it mean to trust and how can we conceptualize maybe this idea of trust in innovation or trust in technology? So we developed a white paper and I brought some printed out copies. So if anybody feels like they want to read something more in depth on that afterwards, please come to me. I have some copies with me. And we started kind of looking back at trust from a more philosophical or anthropological perspective and came up with this definition or conceptualization that trust is a future-oriented interpersonal relationship between 2 individuals, or at least 2 individuals, and it involves a prediction about the future. Person A makes a prediction about person B's goodwill or intentions in the future. And this is based on a notion of shared values and beliefs with this other person and vice versa. And so this idea of goodwill or intentions, in this case, can be seen also as a form of trustworthiness. So if I think somebody is trustworthy, I assume that he or she has good intentions towards me in the future. Now, trustworthiness from also a human perspective has kind of, 3 elements can kind of make up this trustworthiness. We have competence, honesty, and vulnerability. And now when we go back from the humans to more technology, we can translate these concepts also to a more technical side. So competence, of course, refers to, I would say, in the case of machine learning, the performance of a technology. So if the technology performs well, in my eyes, then I think it is competent to do what I think it needs to do. Honesty is also a very human trait, but I think in this case, we can translate it to some sort of transparency. If I know what the technology is doing, I will tend to think it's more trustworthy. And the last one, vulnerability, you think, well, that has nothing to do with technology. How can technology be vulnerable? Well, if we don't speak about safety issues. But we actually think there's also ways in which maybe not technology, but organizations can show vulnerability. So an example that is not purely AI or machine learning, but for example, if you buy something on an e-commerce platform, Zalando or Amazon, you often get quite generous rights to return these items. And this is actually a way in which the platform, the seller, makes himself vulnerable to you, because you can return this item if you don't like it, if it gets damaged, if you damage it while you unpack it. They don't really have ways to know why you're returning it, but they let you, they give you this right to return it. And this is actually a form of how you can show also maybe vulnerability in a more technical context. Now, a really important element when we speak about trust is this distinction of having context-specific trust. And I think that's also important when we speak about trust and machine learning, is that we shouldn't aim for generalized trust that people should trust machine learning or trust AI, but they should trust machine learning to do a specific task. And that is a very important distinction that sometimes gets lost, because I might trust an algorithm to give me, the Google search engine to give me a really good result, but I would not trust it for other things with, So this is really, comes from the social sciences, but is an interesting distinction when we speak about technology. Now, in our white paper, we came up with these building blocks of trust, and they're nothing revolutionary, but we just tried to kind of identify certain elements that can create trust in the context of innovation and technology. So the first one, predictability and reliance, is this idea of performance and having a reliant system. So I think my car is trustworthy. I trust my car because it turns on every morning when I use it. Actually, in my case, it's a bike, but I think it's trustworthy because it tends not to have a flat tire when I try to use it in the morning. Second element, certainty, so minimizing the unknown. As we've seen, trust is a future-looking relationship, so there's always this element of uncertainty, not knowing what is going to happen in the future. But if we can minimize uncertainty, we will create trustworthiness. We have transparency, pretty straightforward, receiving information on on the technology, on how it works, for example. Third-party regulation, the guidelines we've mentioned above, I mean, they're soft regulations, so they're not mandatory, but we've also seen now other sort of regulation coming up in the context of innovation. This can also create trust. Of course, if we know that somebody has checked the safety of an application for us, then we tend to trust it more. We have information from trusted partners. That's quite interesting because it shows also that we might not trust technology specifically, but if a good friend of mine tells me, well, I'm using this really, really cool new tool, and it really helps me to structure my workload, for example, in the day, I might trust that tool much more to be good and trustworthy than if I just saw some ad of it on Twitter or some other platform because my good friend recommended it to me. We have this idea of ethos of trust, a climate of generalized trust. I think in the context of technology, that's quite difficult, especially if we speak about technology that is still so rather new and not like machine learning, quite difficult to achieve. But I think, for example, in the case of the pharma industry, we have quite a strong trust that the medicine that they produce are of good quality, and we take them even though we have no idea what is in them. We have mostly no idea how these components work, but through regulation and this idea that these companies, at least for this purpose, are trustworthy, we trust their products. And finally, the cornerstone of our trust framework is the idea of values, and that links a bit back to this idea of trustworthiness that we've spoken of before, the idea that we share some values in common with the innovators, at least that are behind the technology. Because I would argue that actually technology itself does not have values or does not have intentions in that way, but it reflects the intentions and values of the people that are behind it and that developed it. Now, to wrap up, I want to link this framework, this rather theoretical framework, again a little bit to this, these sources of bias I explained earlier, and just mention how actually trying to tackling these biases from a non-technical perspective targets various of these building blocks. So first, we had the data set, and I mean, it's a pretty obvious statement to assure the data set is representative of the population the algorithm will be used on, but we know in reality this is quite difficult to do. But I think there is a responsibility with the engineers that develop it, the data scientists, to make sure that is the case, and also to document it for the people that will then use the algorithm. And here we've also seen that for these biases that are against certain, for example, the gender biases, often it is not enough to simply exclude the variable gender from a data set to have it not be biased against women, for example, because there is a lot of proxies that will then include, that will still reproduce this bias. The next one is, moved a little bit, well, the algorithm, or the more technical part. So of course everyone tests the algorithm and tries to avoid these biases. And now also kind of in relation to this idea of regulation and transparency, this idea of auditing algorithms. So I don't think this should become a general thing, but I think for certain applications, this idea of auditing algorithms for biases can be quite interesting also for a company that deploys it, because it means some external party has checked that the algorithm at least fulfills a standard with regard to safety and also biases. We have the programmers, and here what we think is interesting is that I called it here ethics training for data scientists, but we actually think that it's important to identify at which moments of the development of a machine learning tool or any kind of application, there needs to be some ethical reflection. And like I said, again, it's not about saying, yeah, you cannot do this and you cannot do that, but just to reflect on which decisions are being taken and then kind of make the programmers aware that these will have consequences afterwards. And finally, a point that I've made before, the users, the end users, or the people that deploy it, to actively inform the intended targeted users on the limitations, especially of these applications, and also on what actually the output means that they will see. So that 78.59% does not mean that that we have a right yes/no answer for a specific problem. That was it, just a philosophical perspective on bias. And if you have any questions and if you're interested in the white paper, please come to me afterwards.